Splitting a fraction. Suppose we start with a compound algebraic fraction 7x plus 19, x plus 1, x plus 5. How do we perform the reverse process of expressing it as the sum of partial fractions? The process of transforming a compound algebraic fraction into a sum of partial fractions is called resolution into partial fractions. By convention, our partial fractions must be proper in the sense that the degree of the numerator must be less than the degree of the denominator. For example, ax plus b all over as squared plus bx plus c. From the above, the degree of ax plus b is less than the degree of as squared plus bx plus c. The partial fraction for any compound fraction will be determined strictly by the nature of the factors at the denominator. Let us start from the fraction 7x plus 19 over x plus 1, x plus 5. And now let's attempt to obtain the partial fraction. Note again, by our convention, the degree of the numerator must be less than the degree of the denominator for any partial fraction. Don't forget. Also, the partial fraction is determined by the nature of the factors at the denominator of the compound fraction. Hence, writing 7x plus 19 over x plus 1, x plus 5 as equals to a over x plus 1 plus b over x plus 5 is quite in order. So combining the fraction at the right hand side, so we'll have 7x plus 19, x plus 1, x plus 5 equals to a x plus 5 plus b x plus 1 all over x plus 1 x plus 5. That is if you cross multiply. Now multiplying both sides by the common denominator, that is x plus 1, x plus 5. So we'll have this. So this cancel this and this cancel this. Hence, 7x plus 19 is equals to a x plus 5 plus b x plus 1. So if we check this, you will observe that it's an identity and must be equal for all value of x. Note the difference between an identity and equation. One, an identity is true for all value of x, while an equation is true for some value of x. Now, coming over to the identity, 7x plus 19 equals to a x plus 5 plus b x plus 1. Let's call that our equation 1. Substituting the roots or zeros of x plus 5, x plus 1 can help. That is, to find b, find the 0 of x plus 5. That is, x plus 5 equals to 0. So if plus 5 cross over to the equality sign, our x is equals to minus 5. Then put it into equation 1 to get 7 bracket minus 5 plus 19 equals to a minus 5 plus 5 plus b minus 5 plus 1. So that will give us minus 35 plus 19 equals to minus 4b. So solving that, we'll have minus 16 equals to minus 4b. Now, dividing both sides by minus 4, our b will be equals to 4. Now, to find a, find the 0 of x plus 1. That is, x plus 1 equals to 0. If plus 1 cross over, we'll have our x as minus 1. Then put it into equation 1. So we'll get 7 bracket minus 1 plus 19 equals to a minus 5 plus 5 plus b minus 1 plus 1. That will give us minus 7 plus 19 equals to 4a. So if we solve that, our a will be equals to 3. Hence, 7x plus 19 all over x plus 1, x plus 5 will be equals to 3 over x plus 1 plus 4 over x plus 5. Now, alternative method of solving this, we can also equate the coefficients of the two expressions at the right hand side and the left hand side. Note, in polynomial, we stated that if p of x is equals to a sub n x power n plus a sub n minus 1 x raised power n minus 1 plus till a sub 2 x squared plus a sub 1x plus a naught, and q of x equals to b sub n x raised power n plus b sub n minus 1 x raised power n minus 1 plus till b sub 2 x squared plus b sub 1x plus b naught are equal. Then, if they are equal, that means our a sub n is equals to b sub n, while a sub n minus 1 is equals to b sub n minus 1, till our a sub 2 is equals to b sub 2, a sub 1 is equals to b sub 1, a naught is equals to b naught. Now, therefore, our 7x plus 19 is equals to a x plus 5 plus b x plus 1. That's equals to, multiply that, we'll have ax plus 5a plus bx plus b. Collecting like terms, we will have ax plus bx plus 5a plus b. Factorizing it, we'll have a plus b x plus 5a plus b. Now, equating the coefficient of x, we'll have a plus b equals to 7. That's our equation 1. Now, equating the constant terms, we'll have 5a plus b equals to 19. That's equation 2. Now, solving equation 1 and equation 2 simultaneously, a plus b will be equals to 7. That is 1. 5a plus b is equals to 19. That is 2. Now, from there, make a sort of formula from equation 1. So our a will be equals to 7 minus b. So we'll name that equation 3. Now, let's put equation 3 into equation 2 to obtain 5 bracket 7 minus b plus b equals to 19. If we solve that, we'll have 35 minus 5b plus b equals to 19. So you solve this again, so have 35 minus 4b equals to 19. So minus 4b is equals to 19 minus 35. That is if 35 crossover, that's collecting like terms. So we have minus 4b equals to minus 16. So dividing both sides by minus 4, our b will be equals to 4. Now let's put b equals to 4 into equation 3 to obtain a equals to 7 minus 4. So that will give us 3. Therefore, our a is equals to 3. Our b is equals to 4. Hence, 7x plus 19 all over x plus 1, x plus 5 is equals to 3 over x plus 1 plus 4 over x plus 5. So this method is called the method of comparing coefficients, and is justified by the statement on the equality of two polynomials. Please do want to subscribe to Elijah Maths class for more of this. Thank you.